Hello everyone, I hope you guys are doing well. And for today's class, we'll be talking about position and velocity measurements. So, how to use sensors to measure position and velocity. And we'll be starting with something you already know. Those are potentiometers. And we know that potentiometers are passive electronic components that vary in resistance. So they have a dial, and when you move the dial in one direction, the resistance increases, and if you move them in other direction, the resistance decreases, right? So what it basically means is that resistance is directly proportional to the angle, and using that we can add a proportionality constant, and we can say that uh, once we figure out the proportionality constant, we can get we can get the angular value theta if we have the resistance value, right? Yeah, and we can also translate it into this form because we know voltage is directly proportional to IR, and V is V is also directly proportional to R, and we can say that V is directly proportional to theta, and so we end up with this equation where your proportionality constant K pot is your voltage by angle. Why we do this is because in an active circuit, it's difficult to measure resistance than measuring voltage in a circuit, right? Uh, so what we can do is we can build a voltage divider circuit. So this will be a constant resistance, normal resistor, and the other one you can connect the potentiometer, and the voltage across the potentiometer can be calculated using the voltage divider rule, and using that you can figure out how much voltage drop there is across the potentiometer. So this voltage drop would be the voltage that we would be using to find the angle. So how we are gonna find the K pot is uh, we can put the potentiometer at 0 position, and we can move it to 45 degrees, and we can move it to 90 degrees, right? Or we can move it to 45 and minus 45, and s- the so when we move it from 0, so at 0 we'll have a voltage reading of V1, and which ideally should be 0, but you may or you may not have 0, and at 45 degrees you'll have V2, and minus 45 degrees you'll have V3. So from those three values you'll have 3k potential values, because you know that so one of the k pot 1 would be V1 by theta 1, which is equal to 0. K pot 2 would be V2 by theta 2, which would be 1, and K pot 3 would be V3 by theta 3, which would be sorry, 45 and minus 45, right? So using this we can we'll get the K pot value. uh, so I so what I suggest is, like, don't use this because you'll get infinity if it's 0. And so what you can do is you can replace this by taking the entire range, which is 90 degrees, and you know the difference between, so this would be V3 uh, V2 minus V3, right? So you can replace this by V2 minus V3 by 90 degrees, or yeah, 90 degrees. So you'll have three K potential values, and using these three values you can take an average, and that would be your K pot. So now once you have your K pot, you can get the one if you have the voltage value, you can get the angle value directly. So yeah, so that's one of the ways to find out the angle of a moving object in a circuit using a circuit. So the other way is to use encoders. So there are different types of encoders, but for this, we'll be using optical encoders. Optical encoders are nothing but encoders that use light to find out the angle. So for in encoders, you basically have a disk which has multiple s- slits or holes in it. So the way we find out the angle moved is by finding the count. So uh, so you'll have an LED on one side of the disk and a photo sensor on the other side of the disk. So the photo sensor can be a photo transistor, photo resistor, or any kind of photo sensor. So what happens is when you rotate the disk, you the photo sensor will detect the light once, and when if it gets blocked uh, by the disk, it won't detect the light. So you'll get a value of 1 or 0. So using this value, you can know if how much the disk has moved. So if, for example, like if the disk moves from here to here, you will have a count value of 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So usually the disk encoders are made in such a way that the disk has a resolution. This resolution uh, so this resolution can vary. So usually, sometimes it can be 1024. So this means there are 1024 slits in the entire disk. So if you go from 0 to 360, the count value would be 1024, right? So that's how you can detect how much angle it moved. So it's basically the same principle. If you have the count, it's directly proportional to theta, and from theta you can get a k. You can use a proportionality constant k, and you can find the k using the same procedure that we did for the potentiometer. So you can take the three angles, and using that you can find out the k. And once you have the k, you can get the one. So if you have the theta value, n value, you can get the theta value, right? But there is a problem in this case. So uh, here you know that how much angle the disk moved, but you don't know if it moved in if you don't know if it moved in clockwise direction or anti-clockwise direction, because it would record one if it moved in clockwise direction. If it would record it would also record if you moved in the anti-clockwise direction, right? So to solve this, what they do is they add two rows of slots, two rows of slits instead of one. So what it does is, so here you can see if here like and they are arranged in such a way that if you rotate in one direction, in this case if you rotate it in clock anti-clockwise direction, the inner slit will be recorded first, and the outer slit changes value after the inner one changes. So the first value changes first, and the second value changes after the first value. So but if you rotate it in the other direction, the second value updates first and the first value updates later. So using this you can know which direction the uh, disk moved exactly. But even with if we know the rotation, there is another problem. The problem is that you don't know the initial starting position, because if for incremental encoders, wherever you start the device at, for example, if you start when you turn on the device, if the LED starts, if the disk is at this position, this would be your zero value. If it's at this position, this would be your zero value, and if it's at this position, this would be your zero value. So there is no absolute value. You can't know how much angle, like the absolute angle it rotated by. So for example, if the object moves from here to here, and you turn off the device and you turn it back on, it will say it is at zero and it didn't move. So that's something to remember. So to overcome this, uh, they use absolute encoders, and absolute encoders are designed in a similar way. So in absolute encoders, you have the same LEDs, you have the photosensors, and but the disk now has a coded, uh, so it has a coded slits. So for example, like if it's at this angle, it would have a specific code that tells it that the object is at this angle, right? Because here it will say that, so the for example here the code would be 1 1 0 0 1 0 1. So for every single angular position, there is a specific code that gets detected, and using that, they know exactly which position the encoder is at. So you know exactly which theta it is at. That's the reason why it's called absolute encoder. And for the next part, we'll be learning about how to measure angular velocity. So for angular velocity, we'll be using a tachometer. So generally, tachometer is a small DC motor that generates electricity. So it generates voltage if you rotate the shaft, right? So be, uh, so the voltage generated is directly proportional to the angular velocity. So if you rotate the shaft faster, the voltage generated is higher, and if the rotation is slower, the voltage is it's smaller. So it's the same concept as before. If you uh, add a proportionality constant, you can find the proportionality constant, and using that proportionality constant, if you have the voltage generated by the tachometer, it you can find out the angular velocity, right? So uh, yeah, so that's everything, I guess. Yeah, so mm, that's how you can find positions and velocity using potentiometer, encoders, and tachometers. Thank you. Have a nice day.